Hello all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we learn about parameter passing mechanism in C. In the last video lecture, we have discussed about the various concepts of functions. So related to functions, we have parameters. We have seen what is a parameter. So parameters are available in the calling function. So the parameters which are available in the calling function, they are called as actual parameters, and the parameters which are there in the called function, so those are formal parameters. So actual parameters and formal parameters. So how these parameters are passed and what is the effect of, so if you change formal parameters, so what is the effect of that on actual parameters? So that we'll see here in this video lecture. So first let us go through once again what is function, what are the types of functions, and with some example. So function is a self-contained block or a subprogram of one or more statements which performs a special task. So when it is called, so main need of function, so in the last video lecture we have discussed the need of functions. So functions are required for code reusability. So the same part of the code can be avoided writing again and again by means of using functions. Then another concept is modularity. So with modularity, modularity is the concept where a larger task can be divided into a simpler, smaller subtask. So with this, the concept of modularity, code optimization. So there are different types of functions available, library functions and user-defined functions. So library functions are predefined functions. These are also called as built-in functions. And then user-defined functions are the functions which are written by the programmer or user. Library functions, so these are called as built-in functions. They have the advantage of being directly usable without being defined. So these are predefined set of functions. The user need not understand, the user does not know the internal working of these functions. So in order to use these functions, we have to include the header file. For example, in order to use the printf and scanf function, we need to include the header file stdio.h. Then in order to include string related functions, we need to include the header file string.h header file. So therefore, these are library functions. Next one is user defined functions. So these are the functions which are defined by the user according to the need of the user, what specific task he or she has to perform. So based upon that, the user can write the function. The user knows the internal working of these functions, and also user understands he or she can change the functions according to their requirement. So related to functions, we have seen this concept, function prototype, definition, and function call. So function prototype, it gives the necessary information to the compiler about the return type of the function, the name of the function, and then the arguments or parameters of the function, or you can say the inputs which the function takes. So function prototype, also called as function declaration. So same as you need to declare a variable before using it, similarly a function need to be declared before using it in the program. So it enables the compiler to verify that the function is correctly called before it is actually defined, before its actual definition is encountered. Next, function prototype. This is the syntax of function prototype. Return type, function name, then parameter list you have. So here number of parameters you can have. So these are the inputs to the function. Next, function definition. It is the actual implementation of the function code where the code is written. So it specifies what the function does when it is called. So function call, so it is a statement that instructs the compiler to execute the function. Function call, so whenever in the program a function call is encountered, so control is transferred to the function definition. So in the program, when function call is there, control is transferred to the function definition, and here the actual code is written. The function call is done. Syntax for function call is function name and then parameters. So we have seen example also for this. So this is the example we have discussed in the previous video lecture. Add numbers this is a function return to add two integers. So this is the prototype, function prototype. So function prototype, this is the return type of this function. So after the execution of this function, it will return an integer value. Name of the function is add numbers, and it takes two arguments or two parameters, two integer parameters. That is int a and int b. So we may or we may not write the parameters, but you have to specify the type of this parameters. So int, just writing this also is more than enough. Int add numbers, name of the function, then after that inside this int comma int. So this is also then after that you have to, this is followed by a semicolon. So whenever the control is transferred here, so int main function will be executed. So here you have declared two variables. So whenever we need to deal with functions, so we need to understand the activation record. So what is activation record? So this is a stack. So whenever we need to deal with functions, so we need to understand. So whenever function is called, corresponding activation record is maintained in the stack. So activation record is an important concept with respect to functions. So what is activation record? So it is nothing but it is a portion of a stack which consists of the local variables, and then return address, and then last one, it also consists of the parameters of the function. So let us understand it with the help of this program. So what is activation record and all? So activation record is a portion of a stack which consists of local variables, return address, and parameters of the function. So what is stack here? So stack is a memory segment. Stack, you can say that it is a memory segment. It is a memory segment which consists of some data or elements. So whenever main function is executed, so here in the main function we have declared two variables, integer variables num1 and num2. So a copy of this, so num1 will be equal to 5. So num1 you have 5. Activation record for main function is created. It is maintained, and in this activation record we have two variables, num1 and num2. So num2 is equal to 10. So this is num2. So activation record for main function is created whenever this function is executed. So here we have two variables, num1, so it is 5, and num2 is equal to 10. So this is 5 and this is 10. Then after that, so along with this, so these are the local variables to this function. Then it also consists of the return address. Then parameters of the function. So it does not take any parameters. So therefore, so these are not there in this function. Next, whenever the control is transferred here, so there is a function call you can see here. So function call is done by specifying the name of the function, and inside this it takes two arguments or two parameters. So these are called as actual parameters. So these are actual parameters, and this function is called as calling function. So this is a function call. This is called as calling function. So whenever the control is transferred here, then this will call when the control is transferred to the function definition. So one more activation record. So in order to execute this function, so activation record for this is also created in the stack. So activation record for the function add numbers. Add numbers, it will take two variables, integer a comma integer b. So add numbers is the function. So one more activation record for this function add numbers is created, and it takes two arguments, int a, int b. So let us understand some few more concepts about stack. So stack is, we have seen that it is a memory segment which consists of data. So related to stack, we have two operations. So in stack, data is retrieved in last in first out fashion. Last in first out fashion, and there are two operations supported in stack. On stack, so these are called as push and pop operations. So what is push means? So push operation is performed whenever we need to insert or whenever we need to place an element or data onto the stack. And pop operation is performed whenever data or elements are to be removed from the stack or they are to be deleted from the stack. Pop operation is performed. So here activation record. So whenever the function control is transferred here, so the control is transferred here to the function definition. Activation record for this function is created, and a copy of these variables. So these are num1 value is passed to the variable A, num2 value is passed to the variable B. Now A and B are local variables so these are the parameters of this function. So this value will be stored. Now A is equal to 5, B is equal to 10. So here in this this is the operation which is performed. A and B values are added. Now A plus B is equal to 15. So sum is equal to 15 now. Sum is equal to 15. So this value of sum is returned to the calling function. So whenever the control is here, so after executing this statement, control is transferred again to the calling function. After the execution of this function, control is again transferred here. So whenever the control is transferred here, so here some value is equal to, so some variable is also there. So this is a variable this is a local variable. Its value is equal to 15. So whenever the control is again transferred to this statement, then activation record for this function is no longer available. Activation record is popped out from the stack. And now the control is again transferred to the main function. So where it left off. So at this point it left off. Now the value of that, so sum is assigned to the variable result. Now result is equal to 15 now. So result is equal to 15. After that, printf statement will be executed. So the output of this will be result is equal to 15. So this is the output of this program. Then whenever the control is transferred here, return 0, then we can understand that, or it gives information that the program is successfully terminated. So activation record after the execution of this main function, the activation record for this main function is also popped out from the stack. So in this way, so whenever a function is called, activation record for that particular function is created or maintained on the stack, and information in the activation record which is maintained in the stack is local variables of the stack, return address, and then return address specifies where it left off, then parameters of the function. In this way, there is some more information which is available in the activation record which has not been discussed here. So that we'll discuss later on. So in this example, so this is a function to add two integers. So we have seen that functions can have more complex parameter list, including data types, different data types, pointers, or even no arguments at all. The return type also can be different. So the function may or may not have any return type. So based upon the parameters and return type, we have seen the types of functions. Function with no arguments and no return value. Then no arguments and return value. Then function with arguments and no return value. Function with arguments and return value. So function in C can accept arguments which are values or variables passed to the function for processing. Actual parameters. So there are two parameters available, actual and formal. Parameters of calling function are called as actual parameters. So in the example which we have seen, num1 and num2 are actual parameters, and A and B are formal parameters. Now let us see how these parameters, how the function communicates with each other, how the control is transferred to the calling function. And so let us discuss in detail about these different concepts related to parameters, that is call by value and call by reference. So function parameters, so these parameters can be of various types like integers, floating point numbers, characters, arrays or pointers it can be. So parameters can be passed by two ways. So there are two ways in which parameters can be passed. So these are call by value. First one is call by value and the second one is call by reference. So what is call by value and call by reference? So how that we'll see in detail with the help of programs. So this is a program. So let us see this program and then we'll discuss what is call by value. So this is a function, the int main function, the program, this is the main function from where the actual program execution starts. So before using the main function, we need to so whatever function, this is a user defined function. So this is a user defined function. User defined function, we can actually see what are the implementation details, what is the internal working of this function. So this is a simple user defined function where it takes one argument or one parameter. So these are the formal parameters. So these are formal parameters and this is the actual parameter. So here the return type of this function is void. So it does not return anything. Name of the function is modify and it takes one input or one parameter, that is integer value. So in this we have written the statement x is equal to x plus 5. Whatever the value of x is there, so that is added with 5. The result is stored in the variable x. So this function does not return anything. So therefore we have not written any return statement here. So program execution starts from the main function. So num value is a variable num is declared and it is initialized to the value 10. So num is equal to 10 in the main function. Then after that this statement will be executed, modify num. So this is a calling function. This the way we call, so based upon how the parameters are passed from the calling function to the called function. Here this is the calling function and this one is the called function. The way we pass the parameters from the calling to the called function, based upon that there are two types, call by value and call by reference. So first we'll discuss about call by value. So what is call by value here? So in the main function, this is a local variable which is declared in the main function. So num value is initialized to 10. So this is a local variable which is declared in the main function. Its value is 10. So here this is a function call. So whenever there is a function call, so correspondingly activation record for this function is created. Now this function is maintained in the, again a new copy of the variable x is created here. So this num value is passed to the variable x. So now x is also equal to 10. So in this function definition, x value is modified to 10, x value is modified to 15. So x is equal to x plus 5. Already x value is 10. 10 plus 5 is equal to 15. Now x value is equal to 15. So in this x value is changed to 15 now. But we are not returning anything from this function. So therefore after the execution of this function, the control is again transferred here. So there is no return value. Then the next line will be executed, modified value num. So this is no longer, this is a variable, this is a local variable. This is a local variable which is there in the modify function. As soon as the control is transferred to the main function, so no longer the activation record for this is available, for this function is available. So this value is also destroyed here. So therefore num value will be 10 only. So even if you print the value of num, so num is equal to 10. So result will be 10. So that is what. So this is the output of this function. Modified value 10. So this is call by value, you can say. So call by value is nothing but a copy of formal or copy of actual parameters is created. And even if you change the formal parameters, there is no change in the actual parameters. Next one is call by reference. So what is call by reference here? So instead of working on the values, instead of passing values to the called function, we are passing the addresses of the variables here. So let us understand it with the help of this program. So here also we have declared. So in the previous, we need to include the header file #include stdio.h. So here, so this is the header file which is included. After that, we have defined the function. Name or return type is void. Name of the function is modify. So here you can see that we have defined a variable of data type. Data type is integer and this is a pointer variable. So when you declare a variable in this way, *x, so this is a pointer variable which stores the address. So normal variable stores the value, whereas a pointer variable stores the address of another variable. So here let us understand the working of this function. So int main, control is transferred here. So in the main function, num value is equal to 10. So value of this num variable is equal to 10. Suppose this is having the address 1000. So whenever the control is transferred here, so function call is there. So this is call by reference. What we are doing here is we are passing the address of this variable num. So in order to access the value, so just %d num is enough. So in order to print the value of num %d, that value of num can be printed by using the format specifier %d. Now in order to access the address of this num value, the value whatever is there in the num variable, so the address, so this is the operator which is used. So address of operator, this is called as address of operator. It gives the address of this particular variable. So address of num means address of this variable num is passed to the pointer variable. Now x is equal to, x will hold the address of this num variable. Now x is equal to 1000. X is equal to 1000. If we want to access the contents of this, to access the value at this, we need to specify it. We need to use this operator. So *x. So whenever the control is transferred here, after that this is a function call, control is transferred here. So here we are passing the address of this variable. So this address is received by the pointer variable. Now we are actually working on the address of the variable, the contents which are, so *x means *x is equal to 10. So just x means, so x refers to the address of this, x consists of address, *x means the contents at this particular address. So *x you can also write as in this way. So address of this is num. So of 1000 at this particular address, what is the value? 10. So this is the value. So actually we are working on the values. So 10 plus 5. So *x is 10, 10 plus 5 is equal to, so again it is assigned to the pointer variable. So *x now is equal to 15. So value at this particular address is now 15. So num value is equal to 15 now. So even though there is no return type here, so this type of, so after the execution of this line, so there is no statement here written after this statement. So control is transferred again to the statement where it left off. So then after that this line will be executed, modified value, then it will print the value of num. Now if you print the value of num, you can find that this is the output of this particular program. So modified value of num is equal to 15. So in this way, we can understand that in call by value method, so whenever you pass the parameters, call by value, or you can say that pass by value. Whenever you pass the parameters by call by value or pass by value method, so there is no change in the, actually what is done is a copy of actual parameters is copied to the formal parameters. So even if you change the formal parameters, there is no effect on the actual parameters. Whereas in case of call by reference method, So if you pass the parameters by reference, instead of passing the values, if you pass the address, and those addresses are received by, so in order to copy those address, so we have to mention the pointer variables in the function definition. So in call by reference method, we are actually working on addresses rather than values. So therefore, whatever changes you make in the formal parameters, so those changes will be reflected in the actual parameters. So this is the major difference between call by value and call by reference method. So value of actual parameters is passed to the formal parameters. Here you can understand these two methods with the help of one example. Suppose there is a Word file which you have created with the name IARE, and suppose if you save this file, if you save the same file with the name suppose other. So save the same file with the name other. Then if you make any changes to this other file, so those changes will not be reflected in the file IARE. So this is nothing but call by value. So this particular example you can relate to call by value method. Now if you create the file, if you create a Word file IARE, and if you make changes to this file and save the file with the same name, then the changes which you have done, so those will be reflected in the file IARE. So this is the example of call by reference method. So or you can understand it related to call by reference method. So in call by value method, value of actual parameters is passed to the formal parameters. In this type, instead of passing values, addresses are passed. So instead of passing the values, what we are doing is we are passing the addresses of the variables. So any changes made in the formal parameters, it does not affect the actual parameters. So here function operates on addresses rather than values. Then changes made in formal parameters are local to the block of the called function. So those are not reflected in the actual parameters. So here formal arguments or parameters, so these are pointers to the actual parameters. Hence if you make any changes in the formal arguments or parameters, so those changes will be permanent. So those changes will be reflected in the actual parameters also. Now consider one more example. So this is one more program to understand the call by value method. So suppose we need to swap two numbers. So there are two integer variables, 100 and 200. So one is A has and B has the value 200. So we are writing a function to swap these two values. So after this, the output of this function should be 200, A should be 200 and B should be 100. So this we have done. We can do it by using a temporary variable, by using another variable, and then store by using another variable. So this is the logic how you can swap two numbers. So we create one more variable temp. So we shift the contents of this variable or copy the contents of this value to temporary variable. Then B value is assigned to A value is assigned to temp, B is assigned to this one, and then temp value is assigned to B. So in this way you can get A is equal to 200 and B is equal to 100. Next, let us implement this with the help of function. So first one is the header file. Next, this is a function prototype. So this is a function prototype or function declaration. So the return type of this function is void. It does not return anything. Name of the function is swap. So it takes two arguments. There are two parameters of integer type. Then int main function. Program execution starts from here, main function. Then there are two variables declared in this function. So these variables are local to this main function. A is equal to 100 and B is equal to 200. A is equal to 100 and B is equal to 200. So this is a function call. So in the function call, no need to specify the return type. Just no need to specify the data type of this parameter also. Just specify the name of the parameter. So here we are passing the parameters A and B. So after this, the control is transferred to the function definition. So in the function definition, whenever the control is transferred here, the compiler will check this function definition. First line will be checked with this function prototype. If both of them are matching, void, this is if all the parameters are matching in the function prototype and function definition, then it will execute all the statements which are there in the function definition. So here A value and B value, in the activation record for main function, A value is 100, B value is 200. Then another activation record for this swap function is created. Then activation there, X value is, the value of A is actually copied to X. So X is equal to 100 and Y is equal to 200. So these values are copied to the variable X and Y. A and B values are copied to the variables X and Y in the activation record for swap function. So whenever we call this function, X is 100, 2 is equal to X, Y is equal to 200. So now this is the logic which is written. So whatever logic we have discussed here, so that logic is written here. This is the actual code to swap two variables. Now here we are declaring one more variable, temp. So temporary, this is a variable temp. So temp is a variable which is local to this function only. So in the function definition we have declared a variable temp. So this is local to this block only. This variable will be available to this block only. Now what we are doing is we are assigning the value of X to temp. So X value is assigned to temp. Then Y value is assigned to X. So Y is equal to 200. So that is assigned to X. Then temp value is assigned to Y. So in this way, so this is how this code operates, or this logic is evaluated. These statements are evaluated. X is equal to 200 now, Y is equal to 100. So after swap, after this line will be executed. After swap, value of X and Y is 200 and 200. So 200, 100 will be printed on the screen. So this is the output of this program. After this, again, there is no more statement to be executed. The control is transferred again to the calling function. So it does not have any return type. Then it will go to the next line after swap. So it will execute these functions. So whenever the control is transferred here, the activation record for this function is destroyed, and these X values and Y values are no more available to the main function. So in the activation record, A and B values are there. So A value is 100 and B value is equal to 200. So with this statement, value of A and B is equal to 100 and 200 will be printed. So after swap, this is the output of this function. This program, after swap, value of, so first this calling function, the control is transferred here. So this is the printf statement executed. First this printf statement will be executed. Value of X and Y. So here we have written the code. These values are swapped here. X, Y value is 200 and Y value is 100. So X is 200, Y is 100. Then after swap, so when the control is transferred here, this printf statement is executed. So A and B values. So after swap, value of A and B is 100 and 200. So value of A and B is not changed. So A and B values are not changed. So it will remain as it is. So whatever changes we have made in this function definition, so those are not reflected in the actual parameters. So A and B value will remain the same, 100 and 200. So this is an example of call by value method. Next, another one is call by reference method. So same program we'll see for swapping two numbers with, if you pass the address of the variables instead of passing values, so that is called by reference. So this is function declaration. So in the function declaration, so this is a pointer to an integer variable. So X is, so when you mention in this way star X, so this is a pointer to an integer variable. Data type is int. So it is a pointer to an integer variable. So and this is a pointer to an integer variable. So we have declared two pointers, X and Y. So in the main function, we have declared two variables, A and B. A is equal to 100 and B is equal to 200. So correspondingly, it will have some address. So let it be 1000 and 2000. So address of A is 1000 and address of B is 2000. Next, swap. In the swap function, this is a function call. So this is a function call, or you can say that calling function. So this is a function call. In the function call, we need to specify the name of the function and that the parameters. So inside this, instead of pointing the values of the variables, what we are doing is we are passing the address. So we can specify the address of the variable A by this, by the operator, address of operator. So address of B will give this value. So address of A is equal to will be 1000 and address of B will be 2000. So these addresses are passed now. So these address, so after this control is transferred here. So then the compiler will check this one function definition first line with the function prototype. If both are matching, then it will execute these statements. Now let us see how these statements are executed. So these values are received. So ampersand A and ampersand B, that is address of A. So this value will be received by the variable X and Y. So X and Y are pointer variables. Now X will store the address of the variable A and Y will store the address of, to Y variable address of B is passed. Now if you refer to star X, so star X is nothing but star X is equal to ampersand of A. So star of 1000. So at this particular location, what is the value? So that is what it means. So at this particular location, value is 100. Now we have declared one more variable here, integer variable temp. So in order to perform swapping operation, so what we are doing here is, so value at this particular address. So value at this address is star 1000, at this particular address is 100. So that is given to temp. Next, value at this particular address, so star of Y corresponds to Y holds the address of B. So Y holds the address of B, so star of 2000. So star of 2000 means value at this particular address. So that is 200. Now 200 is passed to the variable. Now 200 is changed. 200 value is changed to this particular location, at this particular location. So 200 is changed to, so whatever the contents are present in this address, so they are changed to the contents in this address. So here you will have 200. Now A will be 200. So temp value is 100. Next, after this temp value, the whatever the value of temp is there, so that is assigned to star Y. So star Y means at this particular address, what is the value? So at this, we are assigning the value 100. So in this way, if you go for this statement, after swap, value of X and Y is star X and star Y. So whatever the contents are available at this particular address, so those will be printed. Now, so at this particular address, the value available is 200. So 200 and 100. So these are the values now, 200 and 100. So this is what the printf statement is executed, 200 and 100. Now after this, control is again transferred to the calling function. So this line will be executed, printf statement. So after swap, value of A and B. So value of A and B will also be 200 and 100, because actually we are operating on addresses rather than we are passing the address of the variables instead of passing the values. So therefore, there is change in the formal parameter. There is change in the actual parameters also. So when we do not know when to use these different methods, call by value and call by reference method. So when we do not want to change the original value of the variable, then we can use call by value method. When if suppose we want to make any change in the original value of the variable, then we can use call by reference method. So these are the conditions. So this is a program. Now let us see some more programs. So this is a program, a user defined function with no argument and no return type. So here we have a function definition. So in the function definition, so let us start with here int main function. So in the here this is a function call. The name of the function is fun1. So control is transferred here. So whenever control is transferred here, So this, whatever the statements which are there in the function, those statements will be executed. So here in this, we have declared a local variable array. So this is an array of size 10, which is initialized to the values 1 to 6. Now we have declared another variables. So these are also local to this function f1, so I is equal to 0, sum is equal to 0. So this function is written. This task of this function is to add all the values of the array. So whatever the values are there in this array, we have to add them. That is what the task of this function is. So in order to access each element of the array, we know that we have to use for loop. So starting element of the array can be accessed by using the index 0, and the last element can be accessed by using the index the size minus 1. So here 1, 2, 3, 4, 5, 6. 6 elements are there. So last element can be accessed by 6 minus 1, that is 5. So loop will run 6 times. So for I is equal to 0, I less than 6. What we have to do is we have declared a variable sum. Sum is equal to initial value of sum is 0. So 0 plus array of 0 will be added first. So array of 0 is 1. Now sum is equal to 1. Again I value is incremented by 1. It will check the condition. The condition is true. Next another element will be added. So 1 plus 2. In this way all the elements of the array will be added. So output of this will be 21. So when you add all these values, so sum of all the array elements is 21. So again, after the execution of these statements, control is transferred here. So there are no more statements to be executed in this function. So program will be terminated. So in this way, so this is also one example of a user-defined function where we don't have any arguments and there is no return type also. This function is not returning anything to the calling function. So so this is all about user-defined functions, and so in this video lecture we have discussed about user-defined functions and the important concept in user-defined functions, how to pass the parameters. So parameter passing mechanism, there are two ways. First one, pass by value or pass by reference. So or you can say call by value and call by reference. So in call by value method, just a copy of actual parameters is copied to the formal parameters, and if you change the values of the formal parameters, those changes will not be reflected in the actual parameters. Now in call by reference method, so what we are doing is, instead of passing the values, we are passing the address of the variables. So the changes which we are doing in the formal parameters, those changes are reflected in the actual parameters also. So that is all about in this video lecture. So in next video lecture, we'll discuss some more topics of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.